Yes, to all our viewers out there and the lovers of Philosopher, I want to say thank you very, very much. So, as you can see in this video, I'm going to be talking about the boiling and melting point variability of the alkyl halides. And I'm going to be talking about three major perspectives under this video. And as you can see on the board, perspective one is talking about a fixed alkyl group and a variable halide group. And point number two is talking about a fixed halide group and a variable alkyl group. And the last but not the least is talking about substituted alkyl with more halides. Yes, in exams and if both internal and external exams, even as an undergraduate student, 200 level, taking organic chemistry course, you are going to be asked to arrange in descending and ascending order of boiling and melting point of the following alkyl. And the first thing you have to check is that which perspective are they testing you are on. It can either be that they fix their key group and vary the halogens, and sometimes it can be that they fix the halide group and they vary their key group, and sometimes they might be testing you on substituted alkyl halides. Yes, they can be testing you on substituted alkyl halides. Yes, don't mind this, just a breeze. And yes, they might be testing you on substituted alkyl and these are the variability. Now, if you see the examples I gave in front, you will see that in this case, the alkyl group is constant, methyl, 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 all true, and the halide is variable. They change the halides. And in case two, you notice that this is butyl, propyl, ethyl, methyl, but the halogen is constant, which is chloro, 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 fixed halide. And the last one, substituted alkyl with more halides. In this place, there are three hydrogen and one chloro. But as you proceed forward, the hydrogen decreased by one, which is now two, and the chloro increased by one. So the hydrogen decreased by two, and then the chloro increased by two as well. Then there'll be a point whereby all the hydrogen with the carbon will be substituted and be replaced by an halogen. So these are the three ways they can test you on this. Now, this is the analysis. First of all, you have to know that in terms of halide variation, iodine has the highest boiling and melting point as a briefing. So iodine first, then followed by bromine, followed by chlorine, and followed by fluorine. So when you're arranging in decreasing order, please, you are going to be using greater than symbol. Greater than means iodine is greater than bromine, which is correct, and bromine is greater than chloro, and chloro is greater than fluoro. The explanation behind this hierarchy is because iodine is said to have the largest atomic number, and your atomic number depicts the size of your nucleus of your atom, and it means iodine has bigger atomic size. And the larger the quantity or the weight of an element, the higher the boiling and melting point. Since iodine is 80 something atomic number, then definitely it's going to be more difficult to boil and melt. So it has the highest, followed by bromine, followed by chlorine, and the least, the most easily that you can easily boil or melt is fluorine. So in increasing order, then you are going to start from fluorine, fluorine less than chlorine. Is increasing order is less than symbol, decreasing order is greater than symbol. As you can see, as I've highlighted here. The second part of the analysis is this second part. When you have a fixed halide but you have a variable alkyl group. In this case, butyl is not the same as propyl. So you will believe with me that butyl has 4 carbon, while propyl has 3 carbon. Ethyl has 2 carbon, and methyl has just only 1 carbon. So in this hierarchy too, out of the first four alkyl attachment group, methyl, ethyl, propyl, and butyl C4H9 has the highest boiling and melting point. It means the larger the number of carbon in your chain, the higher the boiling and melting point. So what will determine the arrangement of case 2, these examples that I gave in case 2, is the number of carbon. So this carbon has the largest number of carbon, C4. That means it's going to be the highest, followed by the person that have 3, followed by the compound that have 2, and followed by the last guy, methyl chloride. That is why in my arrangement, if I'm writing in decreasing order, I'm going to start from butyl, greater than propyl, greater than ethyl, ethyl greater than methyl. So that means butyl chloride will be greater than propyl chloride will be greater than ethyl chloride, and respectively, ethyl chloride is going to be greater than methyl chloride. But if you want to go in decreasing order, if you move from here to here, this direction, that's decreasing order, using greater than. If you want to go backward, it's going to be less than methyl chloride less than ethyl chloride, ethyl chloride less than propyl chloride, and propyl chloride less than butyl chloride. That's increasing order. For increasing order, you are going to use less than symbol. For decreasing order, you are going to use greater than symbol. And finally, substituted alkyl. Now, if you see this one, the number of chloro that is attached to it is 4, followed by this one 3, 2, and 1. That means the most substituted alkylhalide we have the highest boiling point. So because halogens have higher atomic weight, chlorine for instance, chlorine is having 17 atomic number, while hydrogen only have 1. So it means any compound that you see that have the largest number of halogen is going to have a large number of boiling points. So tetrachloromethane is greater than trichloromethane, while trichloromethane is greater than dichloromethane, while dichloro is greater than methylchloride or chloromethane. So, but if you want to go in the other way around, you are going to use less than rotation, and that's increasing order. Methylchloride is not as high in boiling and melting points compared to dichloride. Yes, methane dichloride, and methane dichloride is not as high compared to methane trichloride, and the highest of them all is tetrachloromethane. You can also go and research more online. The summary of this video is just to tell you that they can test you on arrangement of boiling and melting point in various ways. But what you have to know is that for you to show relationship, the greater than symbol is to show decreasing order, and the less than symbol is to show increasing order. Decreasing order means come from the highest to the lowest. In terms of halogens, iodine is the highest, then you bring it down onto fluorine. In terms of alkyl attachment, the lowest is methyl, while the highest, when we are talking about phosphor alkyl group, is butyl. Butyl is higher than propyl, propyl is higher than ethyl, and ethyl is higher than methyl. So if you check for the chain, who has butyl? So any halogen that have butyl attached to it will be the highest in the arrangement. And don't forget that decreasing order is from highest to lowest using greater than symbol. Increasing order is from lowest to highest using less than symbol. And finally, when you come to substituted alkylhalide, any alkylhalide that have the larger number of halogen involved, like our CCl4 that has no hydrogen at all, our CCl4 that have no hydrogen at all, we have the highest boiling and melting points compared to others. I hope you have been. These are the three major ways you can be tested in most exams. I hope you have learned something valuable from this video. Thank you very much. Please don't stop liking us, don't stop commenting, don't stop sharing, don't stop recommending, and please don't stop giving me that love emoji. I love you so much, guys. Thank you very much. Greetings from you graduates education Nigeria. Once again, I'm by name Phillips Olamide Oladele, philosopher, your tutor and your friend. Enjoy your day. Bye.